Hello everybody, and welcome to our class on selections, joins, and relates. This class will help you develop some of the most basic and fundamental skills in any GIS analysis. Here we're going to learn how to apply an analysis to a subset of the data. As a bonus, we're going to learn how to connect up datasets so you can query one dataset and extract information from other datasets based on the results. Now, just a heads up, once you got this down, you're going to see that the methods are pretty easy and fairly straightforward. However, there are aspects to using the tools that are a little confusing, so it's not hard to learn what you want to do, but it's a little tricky to learn how to tell ArcGIS to do what you want it to. Also, the lab exercises and the homework for this lesson are a little tedious, and my apologies in advance. However, I believe that learning this topic requires developing muscle memory as much as learning the logic. So you got to do it over and over to kind of burn it in, and so that's why you're going to be doing that. So let's dive in. Why do we select? Well, first off, it lets us zoom to features, and ArcGIS Pro offers several easy tools to zoom in right to selected features, and this is especially useful if I select a feature in the attribute table but don't know where it is on the landscape. And for example, suppose I can't remember exactly where Yavapai County is in Arizona. I could find and select that county in the attribute table, then zoom my map right to it. Or, as I'm doing in this slide, I can select a few features I'm interested in and expand the map so I get the closest view possible of the landscape that contains all these features. I can get statistics on subsets of features. Now, remember, GIS is all about getting information on objects in the landscape. As part of this, there must be some way to decide which features you want to analyze. Most analyses are only done on a subset of available features. For example, I might be interested in the amount of roadless areas in a forest, and therefore I want to identify all parts of the forest that are greater than some specified distance from a road. But I might not want to consider those roads that are so bad that hardly anybody can get out on them. Therefore, I would select only those roads that were not these bad roads, and then I'd run the analysis on the selected set of roads. In this example, I'm interested in whether some counties have a higher median age than others, and I can easily open up a histogram to see the distribution. There's lots of these kind of simple statistical descriptors you can generate about your data. Now I can run tools on just subsets of features, and there are many tools like that statistics tool we just looked at that you might want to run on only a subset of features. For example, I might have a set of spotted owl locations that are collected during both the day and the night. I can compare both the nocturnal and diurnal behavior and habitat use by selecting the day or night locations before running the tools. And when I do that, the tools only consider those selected features. I can save subsets of features, and sometimes a dataset has far more data in it that you want to work with. For example, you might have a road network dataset of the entire country, millions of roads, but you only want to work with the roads in your forest or town. You could select those roads you're interested in, then save them to a new and much smaller feature class. This has the advantage of making the feature class much quicker to work with because ArcGIS is not having to examine the road network for the entire country every time you change the map view. And also, there are inconsistencies in the hundreds of ArcGIS tools and commands with regards to selections. Some will work on only the selected features, some work on all features regardless of whether there's a selection, and some give you the option. Now, if a tool doesn't give you the option to only work with selected features, then you can save a subset of the features to a new feature class, and then you run the tool on that new feature class. Now let's discuss how to select. You can select by clicking or drawing on the screen. You can select by clicking on records or rows in a table. You can select by using the Select by Location tool to select features based on proximity to other features. And you can select by the Select by Attributes tool to build complex queries for tables. Now, what is a selection? Suppose I have a road network on the Coconino National Forest, and I'm curious how much of the road is available and open to all vehicles, including ATVs and snowmobiles, throughout the year. By selecting just those roads which are defined as, quote, roads open to all vehicles year-long, I can now analyze them as a group. Selected features usually show up in cyan, but you can change this color if you want. Now, for example, I can easily calculate how much of the Coconino Road network is classified this way, and I see 5,103 miles. I can see how much is not classified, 2,670 miles. And you may also find it interesting, like I do, that the Coconino National Forest has over 7,700 miles of road on it, which, if you stretched all these roads out in a straight line, is enough to take you a third of the way around the planet. Now, I can also zoom or pan to selected features. For example, I can search for a particular feature in the attribute table. I can select that feature and then quickly zoom to it to find it in the map. Some ArcGIS Pro tools will only work on selected features, and other tools give you the option between selected and all features. Now, it's hard to predict which tools check for selection and which don't. You have to read up on them individually, and even then they don't always say. But when in doubt, just select the features you want to analyze and export those selected features to a new feature class and run the tool on that new feature class. That's one way to be absolutely sure. Now, selecting in the map, there are several tools available to select features just by clicking on them or drawing shapes around them in the map. These 6 options in the slide basically are just different shapes you can draw on the screen, and the 3 grayed out options are specific tools for selecting 3-dimensionally. Now, it's just as easy to clear the selection in the map. You just click this clear command. The layer must be set as selectable in order to use these map selection tools. And do you ever wonder why you might want to disable the on-screen selection tools? Well, primarily because you might have several vector layers in your map and you only want to select from a subset of them, and it's kind of distracting and time-consuming for ArcGIS to make the selection on all layers of the map when you only care about one. Say, for example, maybe you have 30 feature classes loaded up. You only want to analyze one of them. If you draw a box around the features you're interested in, then ArcGIS Pro will also select all the intersecting features from the other 29 feature classes. You then have to wait for all those selecting to finish. You have to wait even longer for Pro to symbolize all these newly selected features with this cyan selection color, and you would have saved yourself a lot of time by just setting only that single feature layer to be selectable at the start. You can also achieve this, by the way, just by setting the layers to be not visible, the ones you don't want to select from. Anyway, moving on, selecting by attributes. This particular tool makes it easy to select features based on attribute values, and there's 2 ways to use the tool. Simplest way is this one called the clause mode, and the more sophisticated way is the SQL or SQL version. Both versions have their pros and cons. Standard version, this clause mode, makes it easy to make simple queries, such as finding all features with some attribute value greater than, equal to, or less than some specific value. Tool will also give you all the names of all the attribute fields in a drop-down list, which is nice because we don't always remember the exact name of the attribute field we want to query about. Tool even samples the data as you build the query to offer you some attribute values to compare against in a second drop-down list. Tool does offer a method for building complex queries with multiple subqueries, but it's a little clunky, and it didn't give you any way to use the more interesting SQL operators. SQL window, on the other hand, is generally much more powerful. It'll do everything you can do in clause mode, and sometimes easier. Unfortunately, you need to know SQL to take advantage of it. Tool does try to help. Once you start typing, it'll offer autocomplete suggestions, such as listing the field names and the SQL functions it thinks you want to type. Tool makes it a lot easier to build compound queries. Just need to put things in parentheses like you would do in mathematical terms in algebra, and then separate those parentheses with ands, ors, and nots. Now take a look at this website here. This will give you a list of the SQL operators that ArcGIS recognizes. You can also find this page by just doing a web search for ArcGIS Pro SQL. Now there's a few things to remember about SQL queries. First, if you are querying for text values, such as, I want to select the state name equal to Arizona, or the Ranger District equal to the Mormon Lake District, then you have to enclose your text value in single quotes or apostrophes. Don't use double quotes. You can include wildcard characters, which allow you to search for any text that is contained inside longer strings of text. Wildcard characters also have to be enclosed in these single quotes. Now this raises a problem if you want to include a single quote character in your text search. If this happens, you need to add a second apostrophe in front of the original apostrophe. This serves as an escape character that tells ArcGIS that you want the original apostrophe in the query itself. So you have to deliberately tell it to not consider that apostrophe as sort of the thing that bounds the text query itself. Now, wildcards are pretty cool. They stand in for unknown or unspecified text, and they allow you to search for text inside a longer text. Queries that use wildcards are called like queries, and they use this like operator. Notice you do not use the equals character in these types of queries. Now, as for wildcards, there's two types of wildcards. One stands for any number of characters, including 0 characters. Second stands for exactly one single character. ArcGIS uses the % symbol as the wildcard that stands for any number of characters. In this slide, we are querying for all features that have coconino anywhere in the site name. ArcGIS uses the underscore symbol as the wildcard that stands for exactly one character. In this slide, we are querying for all features that have the text 304 as the second, third, and fourth characters in the name. By the way, there are ways to escape these wildcard characters too, in case you want to search for text that actually has an underscore or a % sign in the text. A little more complicated than just popping an apostrophe in front of it, but SQL does give you tools for it. Now, there are issues with SQL queries. The function is very powerful in that selecting by attributes lets you build complex SQL queries far beyond the simple operators included in the clause mode. However, the query string format depends on the data type. And by data type, I mean things like shapefiles versus file geodatabases versus enterprise geodatabases. Shapefiles and file geodatabases, for example, follow different rules than Microsoft Access databases. High-end databases like Oracle, MySQL, and SQL Server might have their own formatting quirks. For example, wildcard characters might be different. Shapefiles and file geodatabases uses the % and underscore characters like I was just describing, but Microsoft Access databases uses the asterisk for multiple characters and a question mark for single characters. Now, attribute field names should sometimes be enclosed in double quotes, sometimes in square brackets, sometimes in this backwards apostrophe, sometimes not enclosed in anything. And that all depends on the rules of the particular database that you're querying against. Now, if your data are stored in an Esri format, such as shapefiles and geodatabases, then the Select by Attributes tool will automatically format the query correctly. Now, if you're connecting to other types of databases, you'll need to know the rules for that database format. Now, a nice feature if you're using Python is this Add Field Delimiters function. This will check the database for you and make sure your field names are formatted correctly. Now let's talk briefly about null values. These are a special data value that specifically means no value at all. Such values are important because sometimes we actually haven't recorded data for some attribute. The SQL query is attribute is null. Is the operator. There's no equal sign in a null query. They use this is operator. Shapefiles can't hold null values, which is a real mark against them. Now, if you don't have a numeric value, shapefiles store a 0 instead. This is a real problem if the attribute field is some numeric value that has been only measured intermittently. So, for example, if the attribute field holds, say, the measured flow of a spring, then that number represents the actual amount of water coming out of the ground. If we didn't measure it one day, then we'd like to store a null value that says that there's nothing been measured. Shapefiles, unfortunately, will force you to store a 0 value instead. This has real implications for later calculations of like average or minimum flow. Now here's a bonus. Once you've mastered the Select by Attributes tool, you can use a very similar one to set a definition query on a feature dataset. This particular tool makes it easy to select features based on attribute values. The definition queries are part of the layer definition. And remember that layers are just sets of instructions telling ArcGIS where to find and how to draw data. Layer definition is part of the instruction ArcGIS Pro follows when drawing the data. And specifically, definition queries tell ArcGIS Pro exactly which parts of the dataset to show. Now, we may not want to see all the data in the dataset. For example, suppose we have the Coconino National Forest Road Network, but we only want to show those roads that are defined as being open to all vehicles. By setting a definition query, we can tell ArcGIS Pro that this layer should only show the roads that are classified as either roads open to all vehicles year-long and roads open to all vehicles seasonal. So it only shows it on the map, and even better, if you open the attribute table, it only shows those records that meet this query. So ArcGIS only shows us this small subset of data. It shows it to us in this window, it shows it to us on the map, and any analysis we do, any tools we run will only be applied to this subset of data. Okay, so we've been discussing ways that you can select. We talked about clicking on the screen. We talked about selecting by attributes. Now let's talk about selecting by location. This is where you really use GIS. Selecting by location is all about using spatial relationships between different features. You use this select by location tool, and there's lots of spatial selections options, different spatial relationships that you can use. You can select all features of one feature class that intersect some other, or are within a distance, or they contain that other. So we could have all the springs that are contained within the Coconino National Forest, or we could do the other way around. We could do those that are containers. So we could select all the national forests that are containers for a particular spring. Whole variety of different spatial relationships that you see here in the list. Now you might notice that there's several of them that have the word Clementini in it, and that's worth mentioning. I would say that Clementini relationships are not used that often, but they're kind of interesting, and you should know about them. So the issue is that these relationships like intersect or touch or on point is on the boundary of, these relationships sound reasonable and logical, but different GIS software packages interpret these things differently. So what one software might interpret as intersect, another one might only consider it as touch. So does intersect mean that they can touch on the boundary, or does intersect mean that one has to actually go over the top of another? So different software packages have different definitions of these things. Well, Clementini wrote a paper that tried to standardize the definition. So if you follow Clementini's definition of intersect, for example, then every software that implements Clementini's definitions will perform the operation the same way. So Esri provides these Clementini options, and so you can try them out if you want. I've got Clementini's paper available for you on BBLearn if you like. It should be in the module on selections, joins, and relates. And I'll be honest though, I never use Clementini relationships just because they seem to run a lot slower than the standard ones. So they do conform to a formal definition, but they just run a lot slower. And by the way, these spatial relationships are also available to you if you select by clicking on the screen. The first time you do it, you draw a little box and select all the rows that intersect. Well, that just uses the straight intersection spatial relationship. But if you open up the selection options window, you can set different spatial relationships. So, for example, if you want to just select those features that are wholly contained within your box, then you can set that option here. So, a few spatial relationships available, not nearly as extensive as in the true select by location tool, but there's some. And in your lab exercises, and at the end of that document, I have several spatial relationships illustrated. So if you want to know what would be considered a true intersection, then this appendix will help clarify that. Now let me quickly demonstrate this select by location function. Okay, suppose that we want to select all the springs on the Coconino National Forest based on their proximity to roads. Say we just want to select all springs within 100 meters of any road on the Coconino. We start by popping open the Select by Location tool, and I want to kind of explain this window a little bit. All right, the input features, these are all the features that will become selected after we run this function. And I'm wanting to select springs, so my springs will be the input feature. The relationship, this is the spatial relationship that we use to say that we want all the springs within 100 meters. This is how we define that relationship. Now you might notice there are several different functions that could serve this purpose. There's within a distance. We could actually even use intersect with a search distance. Intersect would find all the points that touch a road plus all the points within 100 meters. Now, of these options, the most accurate is this option, within a distance geodesic, and we're going to learn why that's most accurate in the lecture on projections and datums. But for the time being, let's just go with this one for now. Now, the selecting features, these are the objects that we are comparing our springs to in order to decide whether they're close enough. So we're going to use the roads feature class for this. The search distance is pretty straightforward, right? It's just, here's where we say 100 meters. And we're going to talk about selection type in the second part of this selections lecture. So for the time being, let's just go with new selection. Right? And we're going to hit apply. Remember, apply and OK. The difference is apply will run the function and leave this tool open. OK will run the function and close it. So let's just hit apply for now. It has performed its selection. We see a few springs become selected. An easy way to see how many, just click on this sort or list by selection option. We see that there are 221 springs selected. All right, so easy enough. Now suppose we want to take this a step further. Maybe we're really interested in the springs that are nearest the highest quality roads. If the road is paved, then it's probably going to get more traffic, right? And so springs that are close to the high quality roads are therefore probably going to get a lot more human visitation. So if we want to just restrict our selection to proximity to the best roads, well, first we have to select those roads and then run the select by location tool again. All right, so first let's select the roads, the Coconina roads, and we're just going to go with these two highest classes, the moderate degree of user comfort and the high degree of user comfort. So let's get that. Let's hit select by attributes. Now in this case, we can use an operator contains the text. The operation maintenance level, that's the field here that's being symbolized by, contains the text user comfort, and that'll capture these last two. We could look at the SQL version of this. You might notice it's a light query. It's using wildcards, these percent signs, and we can verify it's a good one. That's a valid expression. I'm going to hit OK because I want to close this dialog after it runs. Okay, I did that. You see the best roads became selected here. Just check the count. Looks like there's 222 roads that are these highest quality. All right, so now let's run the select by location tool again. But this time, since the roads have a selection on them, then the tool will only consider those selected roads when it runs. So let's hit apply. Okay, so most of those selected springs became unselected. There's a few that are selected still right next to the good roads, not surprisingly. And we can tell here that there are 25 such springs that are close to these highest quality roads. That's all there is to it. Okay, I think that's enough for the first part of this lecture. So far we've covered different ways to select and why you would select, how to calculate simple statistics from a selection. And in the next lecture, we'll discuss these selection types that I mentioned before. And these are really critical, and they actually cause a lot of confusion. When you make a selection, is a brand new selection, or are you selecting from some currently selected set? There's a few other options, so we'll go over those. We'll also talk a lot about multi-criteria selections. These are more complicated and really more like the real world. Then we'll talk about joins and relates and relationship classes. All right, thanks so much.